This is the last unit for part 1. This is lesson 10. Okay, I believe we're going to be looking at graphs and factors in standard form, kind of going back and forth with those, talking about what are my zeros of my function, where I'm crossing the y-intercept, those sort of things. Okay, hey, let's get a review here from the last lesson. Okay, write an equivalent expression for 2x plus 5x, 2x plus 5 times x plus 1 in standard form. And we've got another one. We've got another one here. So what I'm going to do, guys, is first try to be able to draw here. If it's going to let me. Let's do the box method on the first one. So 2x plus 5. Okay, there's my vertical one here, and then x plus 1. You guys have done the two ways. Okay, and so remember, guys, we multiply the terms that are there. So it'd be like 2x and an x give you 2x squared. Okay, 5 times x is 5x. 2x times 1 is 2x. And then 5 times 1 is 5. Okay, from there, guys, remember our like terms always kind of reside here in the middle. Okay, and so what we're going to get then is going to be a 2x squared plus 5x and 2x give me 7x plus 5. Okay, on this next one, let's FOIL. Okay, so remember FOIL is first, outside, inside, and last. So if I do the first terms, I'm going to get x times x, so it's x squared. Then I'm going to do the outside, x plus 2, or times 2, so 2x. Then I'm going to do the inside, negative 2 times x, so it's going to be a minus 2x. And then I'm going to do last, negative 2 times 2 is a negative 4. We know, hey, this is a difference of squares, so these middle two will cancel out. And I am left with just x squared minus 4. Okay? All right. Let's dive into what we're going to learn for today. Okay, here's a graph equal 8 minus 2x. What do you see the 8 from the equation of the graph? We see the 8 is where the line crosses the y-intercept, right? So we see it right here. What about the negative 2? Well, we see, guys, that the negative 2, and we know that it's with the x, so the negative 2 is the slope of the line. It's going down 2 over 1 each time, so down 2 over 1, down 2 over 1. So we know that. What is the x-intercept of the graph? That is right here. So remember, we're looking at the x value, and so it'd be 4, 0. Okay, and what does the x-intercept relate to this equation? Or how does the x-intercept relate to this equation? So we talk about, we see the negative 2, you know, it is the solution to the problem 8 minus 2x, you know. So if I had 8 minus 2x, what makes y 0? It's 4. Okay, in the earlier lesson, we saw an equation such that h of t equals 10 plus 78t minus 16t squared can model the height of an object thrown upward from a height of 10 feet with a vertical velocity of 78 feet per second. Okay, so we know that, hey, the 10, the constant term, is where I'm starting. Okay, that's where I'm going. This is my kind of linear velocity. Okay, and then we know the negative 16t squared represents the pull of gravity over t seconds. Okay, so is this written in standard form? Yes, because guys, I'm going to tell you, really, and kind of what we've been talking about in my class is that it has a squared term. Okay, it has something squared in it. That's what makes it a quadratic. If it was beyond, or hey, if we're doing this, kind of what I've been saying was it has a degree of 2. Because I'm going to disagree. Oh, and is it written in standard form? Hey, it has a degree of 2. It's going to have the square termed, okay? And so really it has a squared termed, a linear term, and a constant, okay? It really needs at least, just like this, okay? We see here that an equation such as 10 plus 78t minus 16t squared can model the height of an object thrown upward from the height of 10 and a vertical velocity of 78 feet per second. Jada said the expression negative 16t minus 2 times t minus 5 also defines the same function written in factored form. Show that Jada is correct. So what we can do, guys, is we can test Jada and see if she's right. So if I have a negative 16t here, okay, and a negative 2 here, we got a t and a minus 5. So holy smokes, this is going to be some fun, right? So negative 16t and t does give me a negative 16 t squared, because two t's give me this. Negative 2 times t is a negative 2t. Negative 2 times negative 5 is a positive 10. And then negative 16 times negative 5. So let's see. Negative 10 and negative 5 give me 50. A 6 and a 5 give me 30. And so we know this is going to be a positive 80t. Let's hope, right? Let's hope, And so now, guys, we see here that these two are my like terms, just like we always have. And so I'm going to write that as negative 16 t squared plus 78t, and then plus 10. And does that equal this equation here? It does. See how it's written, backwards, but hey, it's still, with addition and subtraction, as long as we carry the same, the same sign, we're good. Kind of like 2 minus 3 is negative 1. Well, negative 3 plus 2 is also negative 1. So we can change up the order as long as my signs carry with the numbers. So yes, Jada is correct. Good job, Jada. In an earlier lesson, we saw that an equation such as h of t, same thing. I'm not going to read it 3 times, my bad. Here's a graph representing both. G of t equals negative 16t minus 2 and t minus 5, and then the same equation in standard form. So guys, remember, we call what g of t here, this is factored form, standard form. So what is the vertical intercept, or in other words, what is the y-intercept? We look here, we see, hey, where am I starting at? Tells us we're starting at a height of 2, right? So that is, remember, it's xy, so 0, 10. What's my horizontal intercept, or where do I land at? We see here, that is 5, 0. Okay, so there we go, we're good. Okay, what does the vertical intercept tell us? Okay, guys, it tells us our starting point, or that the object was thrown upward from a height of 10 feet, which is what they told us, okay? And what does the horizontal intercept 5, 0 mean in this situation? It means that it lands after 5 seconds, right? At 1 second I'm here, 2 seconds, 3 seconds, 4, 5. So it tells us that the object lands at after 5 seconds. Okay? Because again, at 5 seconds I have a height of 0. Remember, the height is a function of time. Okay, what are the x-intercepts, guys? So I can look at the graph here, or what we can start to look at, guys, is that in factored form, the x-intercepts, that's going to be whatever makes one of these parentheses 0. So basically, like, what plus 3 gives me 0, and that's going to be a negative 3, 0. Okay, and then we see here I'm going to have a negative 1, because what plus 1 gives you 0. Negative 1, 0. Okay? And then, guys, what is the y-intercept? Well, it's where I'm crossing, and we see that I'm crossing at 3, so I'm at 3, 0. Okay, and you know what? Actually, it might not. I think when we did this, it didn't like the parentheses to tell me if I'm right or wrong. But we'll see. Those are right. Okay. What are the x-intercepts? Okay, so where do I cross at? Well, I'm going to cross at right here. It tells us, here, it tells us that I'm crossing at 4, 0. I'm crossing at 1, 0. Okay. And so, did I do something wrong on that last one? Now it's bugging me that we did not get a flame emoji, right? Let's go back. Hey, we're at negative 3, we're at negative 1, and we're at 3. Oh, I'm sorry. How about this? 0, 3. That's correct. Not sure what's its problem there, but we do have it correct. I promise it. I promise you. Okay. So we're correct in that aspect. I look at my y-intercept. Where do I cross the graph? At 4. Hey, where else do we see a positive 4 here? We see it here at the end. Okay, because think about it. Hey, what's my x value here? My x value is 0 at the y-intercept. So if I have to plug, remember, it's input, output. So if I plugged in a 0 for my input, what's my output? Well, 0 here and a 0 here would mean that these all would 0 out, and I would just be left with 4. That's another way that we can figure that out too. 0, 4. Okay. So in general, guys, x-intercepts. We can obviously look at a graph, we can definitely see. But in factored form, it's, hey, what makes x minus 3 0? What x value makes it 0? Because again, hey, it's input, output. Well, my output would have to be a 0 y value, see? So we want to know what input gives me a 0 y value, all right? And it would be 3, 0, because 3 minus 3 is 0, and negative 3, 0, because negative 3 plus 3 is 0. And what's my y-intercept? I can look at the end here, and it's going to tell me 0, negative 9. Okay, and we forgot to put parentheses around these. Come on, people. There we go. Okay, got our coordinate points, so we need to make them look like coordinate points. Ooh, here. Notice how it's just an X out here now. How does that change it? Well, we see here that it crosses at 0, 0. So, hey, what X value makes my output 0? It would have to be 0 because 0 is the only thing that equals 0. So if you see an x by itself, it's 0. And then x minus 5, well, that would just be a 5, 0. And we see here on the graph too, guys, it crosses at 5. Now, notice I don't have a c. My c is gone in standard form. Well, it's gone because what number do we not show in a formula? 0. Where do I cross the y-intercept? 0. So 0, 0 is also my intercept. Okay. Hey, the graph looks a little different, okay, but what do we notice? X-intercepts still, guys, are 0, 0, because that x is by itself, and now it's 5 minus what gives you 0? Okay, that's going to be 0, 5, I'm sorry, 5, 0. And then what's my y-intercept again? There is no c in this, there's no constant term, so it's going to be 0, 0. All right. Hey, again, I know I'm going through this fast. All right. I apologize. If I'm going too fast for you, pause the video, rewind the Edpuzzle, and then keep going. Or if I'm going too fast, pause, process, plug it into the notes yourself, then hit play and go again. Okay. Here, guys, what's my x-intercepts? This is crazy because we only have one, right? Because notice, x plus 2, x plus 2. So my factors here are the same, which means I'm only have one solution because I'm only touching the line one time. So that's going to be, a negative 2, 0, because that's what gives me the value. Now, what's my y-intercept? I'm back to having a constant term now. Now I'm back at 0, 4. Okay? That's good stuff. Oh, sorry about that. I think I went way too many slides. We should be here. What do you notice about the x-intercepts, the y-intercepts, and the numbers in the expression defining the function? Okay, so I notice that the x-intercepts are the zeros of my solution. Meaning, guys, where it's where I'm crossing there, so the inputs that give me a 0 output. Okay. Now, guys, what about the y-intercept? I'm going to tell you, hey, I notice the y-intercept is my constant term in standard form. It is my, for lack of better terms, my C, because we know that goes A, B, C. It's my C term, okay? It's my constant. Okay, here is this here, guys. So now without the graph, you know, what x-intercepts do we have? Okay, so what minus 9 gives me 0? All right, 9. If you haven't figured out now, guys, we're just changing the sign. See how it's a negative 9? So it's a 9. This is a negative 1. So what minus 1? It's 1. So 1 would be that. Now predict the y-intercept. This is tough because, hey, you're going to have to multiply those back out to FOIL. But we just need the constant term. So what we can do here is we can cheat a little bit. And as long as my constant c's are at the end of my FOIL, we're going to take this times this. Okay, so negative 9 times negative 1. What's negative 9 times negative 1 is a 9. That's my, when I'm x is 0, we're at 9. Okay, so there we go. All right, and you can do a little bit of input-output too there. We know that, that's the L, but hey, this is a 0, this is a 0. So that's going to be negative 9 times negative 1 gives me a 9. Okay, so is this where we're at? So we're here. How did the x-intercepts of the graph, how'd you do it without graphing? Okay, we zeroed, I don't know how to say this, guys. We solved for each factor. So I'm going to write, this is what I always ask you. What value of x makes the factor equal 0? Okay, so like what minus 9 equals 0? What minus 1 equals 0? Or you guys also, hey, right here we're going to change the sign. Change the sign, because instead of negative 9, we know it's a 9, because 9 minus 0, okay? Instead of a negative 1, it's 1, because we know 1 minus 1 is 0. Okay, how'd you find the x-intercept? We multiplied it out. Or guys, you know it is the L in FOIL. Okay, we know that. It's these two. And so also, you can also, guys, insert zeros for x and then simplify. Okay, put a 0 here, a 0 here, negative 9 times negative 1. Because remember, if here's my graph, okay, here's my t-chart, okay, what x value is that y-intercept? 0. And if it's input-output, I can input a 0 and a 0 in for my inputs to see what is my output. Okay. Oh, come on. There we go. Okay. Did I skip a slide? No. If we graph x minus 7 and x minus 3 and x squared minus 10x plus 21, will it end up in the same graph? Well, let's see. Let's turn this, how do we turn factored form into standard form? Well, what we do is we FOIL it. So I'm going to do first x times x, which gives me x squared. We do outside x times negative 3, so that's a negative 3x. We do inside, so negative 7 times x. So that's a negative 7x. And then we do last, so negative 7 times negative 3 is a positive 21. From here, I have to combine my like terms, which is in the middle. So I do get x squared minus 10x. Oh, I need to do my x here. And then plus 21. Okay, did I get this? I did. So that tells me that yes, they will end up the same. Okay, and I know that these would end up the same graph because we FOILed and converted the factored form into standard form. And so then, guys, guess what we're going to end up doing a little later? We're going to be taking standard form and working into factored form. And I'm telling you, that is when it gets fun. You want to see Mrs. Salmon's excited? Factored form. That's, she loves doing quadratics. So there we go. X minus 7 times x minus 3 in those. What do you notice will be the prediction on the x-intercepts of the graph will be, okay? So guys, we know that, hey, this right here, factored form, will give us the solutions or what outputs equals 0 in this. And so if this is x minus 7, we know that this needs to be a 7, 0. This is a negative 3. We know that this needs to be a 3, 0. Sorry. When we predict the y-intercept, guys, we know that if I look at not factored form, but standard form, the y-intercept is my constant term or my c, and so I see that it's 21. So what that means then at the y-intercept, I have a 0 x value and a 21 as my y value. Okay. What do the x-intercepts of the graph tell us about the quadratic function it represents? Okay, it tells us the solutions to our equation. Okay, it tells us it equals 0. So what x values make it equal 0? Solutions to our equation. All right, and then one more time without graphing, can we do this? Okay, so instead of x plus 2, we know that it's a negative 2 x value that gives me 0. Instead of a positive 4, we know that it's a negative 4, 0 that does this. And then my y value, the y-intercept, again, remember it is the constant term or the c in standard form, so it is an 8. So the x value is 0, the y value is 8. Okay, all right. Usually, guys, I say, hey, this program does not do repetition enough, and I feel like, hey, we drilled down deep. We did numerous examples of this, so I do think right now you should be able to see, hey, this term is this term in factored form or standard form, vice versa, and what can we gather from those? And quickly, what can we gather the necessary things to be able to help us graph like the x-intercepts and the y-intercept of an equation? Okay, guys, that's it. We're done with this unit, which means we're going to test soon, which is awesome. All right, you did it. It's time to do the classwork. Ain't nothing to it but to do it. Reach out to us if you have any questions, and please, please, please have a great